Hi dears, we are discussing about the level of significance, that is confidence interval. Alpha, the level of significance. Alpha and confidence interval, if I say 99% confident, if I say 99% confident, that means 100 minus 1. Okay, that is 99% confident, that is 1% level of significance. It means 1% level of significance. If I say 95% confidence limit, then I am telling that 100 minus 5, that is 95, that is 5% level of significance. So this is all about the level of significance to determine two constants, okay, to determine two constants C1 and C2. So that is what we are going to find. So to determine two constants C1 and C2. Between this C1 and C2, our population parameter lies. That is probability of C1 lesser than our population parameter lesser than C2. So probability that our population parameter theta lies between C1 and C2. How you are doing? Using given that the T is from the sample. Okay, so using the T, we are going to estimate theta. Okay, that is what given T is nothing but 1 minus alpha. So probability will be 1 minus alpha. Alpha is what? 1. If you take 1%, for example, 1%, it will be what it will be 1 minus 0.01. That is, I want to say 99, right? 1.00, 0.01. What it will be? 99% confidence interval. That is what we are used to tell the 99% confidence interval. 1 minus alpha is nothing but confidence interval, right? Alpha is the level of significance. Okay, this made something. I hope you understood something, right? Now the quantity C1 and C2 so determined is known as confidence limits. The quantities C1 and C2 so determined are known as the confidence limits. That is the confidence limit. For example, I am talking about, it will be C1 comma C2. So the theta lies between C1 and C2. This is known as the confidence are known as confidence limits, right? And the interval so this endpoint confidence limits means endpoint C1 and C2. One second. I can say upper limit is C1, lower limit is C2. Like this I can say. So this quantity C1 and C2 are known as the confidence limits. Okay. Now confidence interval. The interval, it may you can take a closed interval or open interval. Okay, the closed interval, if you include C1 and C2, it will be a closed interval. The closed interval within which unknown value of the population parameter is expected. So here only our theta lies. Okay, this interval within which, okay, I'll write it down, within which the unknown value of the population parameter is expected, okay, to lie is known as confidence interval. What do you call this? Okay. 1 minus alpha is called as confident coefficient. Okay, confidence interval for the population mean for large samples when standard deviation is known. That is what the next topic is. We are going to write, find confidence interval for the population mean for large samples. Okay, large samples means more than 30 is known as the large sample, right? When standard is known. Sometimes population standard deviation is known, then only we can use this formula. Okay, what is that formula? If we repeat, if we can take repeated independent random samples of size n. So size of the sample is n. Okay, if we take size of the sample n from the population with an unknown mean but known standard deviation. Suppose sigma standard deviation of population is known, and that is equal to sigma population standard deviation, then the probability that the true population mean that is what we are trying to estimate. Okay, we are trying to estimate the population mean will fall in the following interval is, we are taking the 1 minus alpha as the confidence coefficient. Okay, so probability equal to whatever. Okay, so P equal to x bar, that is the population mean. Okay, Z alpha by 2. Why we are taking alpha by 2? Because its Z value gives only the one part. Okay, 50%. From that only we are taking, that is alpha by 2. Okay, sigma by root n. What is sigma? Standard deviation of the population. N is the size of the sample. Lesser than or equal to where our population mean lies. This interval only we are finding. X bar we took minus there, no, plus. Okay, Z we are taking from the table, alpha by 2. Okay, sigma by root n. What confidence? Alpha, no, 1 minus alpha. Okay, so the confidence interval of the population mean and the standard deviation sigma is known. Okay, that is x bar we can say plus or minus Z alpha by 2 sigma by root n. Right? That is for the confidence interval for population mean mu. Okay, this is the confidence interval for population mean mu. For population mean mu. This is the confidence interval for population mean mu. This is what x bar plus or minus Z alpha by 2 sigma by root n. Okay, for computation of the confidence interval and for testing of significance, the critical values Z alpha at the different level of significance. Okay, what is the next? What we are going to see is for the computation of confidence intervals and for testing of not significance, for testing significance, the critical value, okay, the critical value for testing significance, the critical values Zn at the different level of significance is given below. Okay, what we are going to do is confidence interval we are going to calculate now. For what? For testing the significance. So the critical values Zn. So critical value Zn. Okay, there are two tail test and one tail test are there, that both will see. The level of significance that is alpha. There are different level of significance as we discussed earlier: 1%, 2%, 5%, and 10%. Different level of significance. What are they? %, 2%, 5%, and 10%. This is two-tailed test. If you talk about the two-tailed test and the right-tailed test, and the last one is left-tailed test. Okay, the question arises in your mind: what is two-tailed test and what is right-tailed test and what is left-tailed test? This is our critical values Zn. What are the critical values Zn? Now we'll draw the normal curve. If you have the normal curve, okay, red color, right? In a normal curve, if the critical value lies here, or it may be here, okay, that is means if you take the null hypothesis, H naught, okay, that is, what is H naught says that mu1 equal to mu2. Okay, that is there is no significant difference between, okay, between these two means. Suppose that you are telling that there is no significant difference between these two means, that is mu1 minus mu2 equal to 0. This 0 is known as a null hypothesis. Okay, suppose I have developed a self-learning material. Okay, I have developed a self-learning material. I used in class 1, C1. This is they learned using the self-learning material. I am calling it as experimental group.